Okay, let's take a look at, here is what we were talking about early on the mass spectrometer thing, all right, on how it works. A velocity selector, okay, selects the, I'm sorry, there we go. All right, these two forces will be perpendicular to each other, all right, and then this allows the thing to go straight through, all right, so you get the force in electric field on a charge is equal to QE, all right? The magnetic force is equal to QV times B. Remember, the magnetic force bends that charge around, all right? So in the electric field, this thing is trying to go straight. This magnetic field is going into the page. Velocity is going this way, and this proton is flying through there, so it wants to go up. If you do the right-hand rule, it wants to go up. So the electric field is pushing it down. It wants to go up, and it gets through. All right, so we wind up now, given the values of the electric field and magnetic fields, there will be a single velocity vector that will allow ions to pass through the selector undetected. Now, notice they use V over D here. The B to find the velocity of that. I just like doing V equals Q times E. However, you don't have what do you have on your device? You have a voltage, and you know the distance between the distance in that slit where that charge is going, and V divided by D is equal to the electric field. All right, so that's where they get this voltage over distance. Now, I don't use this formula very often. I've had students on exams use this formula, and it's completely wrong the way they're using it. In other words, they're just grabbing things, going, "Oh, if I can find the velocity," but the voltage was never given. But the selector that you put on your mass spectrometer is probably the voltage, not an E field selector. All right. And so mass spectrometer can be used. So where does this come from? Aha! This is why I had you do that one thing where, let's look at this. So now it enters the electric field, and I'll show you this. So this is notes September 21 lesson. All right, so here it is. So remember we did the mv squared over r because it's going in that arc. We're trying to find the arc is equal to QVB. Once it's inside the area. Let me show you. Right here. So he comes flying through here, goes into the velocity selector, which we can adjust with the voltage, makes it easier. So they do all this fancy stuff here, and they go, and I've seen students use this equation too. You were never given the voltage. You had to use the relationship, this one, to figure it out. But anyway, on an actual mass spectrometer, I'm sure it's the voltage that you set that adjusts this thing, and you know what R is, and so you can find the mass of the particle. Okay, all right. Now the magnetic force. Oh, here comes kind of a quiz question. All right, so if the magnetic force acts on a charge, how does it act on a wire? And this is being way too long. I'm supposed to keep these at 4 or 5 minutes each, but let's just think about that in the next one.